Hello and welcome to the Omnex webinar, Transitioning to AIAG VDA FMEA. Today's presenters are Chad Kymal, CTO of Omnex, and Greg Gruska, FEMA champion for Omnex. Chad Kymal is the CTO and founder of Omnex, an international consulting and training organization headquartered in Ann Arbor, Michigan. Over the course of Chad's successful career, he has served on the Malcolm Baldrige Board of Examiners and has received numerous quality achievement awards, including the Quality Professional of the Year from the American Society for Quality. Chad is also the president of Omnex Systems, a software provider for ISO 9001, 14001, 27001, and many other, including FEMA and control plans. During this webinar, if you have any questions, please enter them in your questions dialog box and we will get to them at the end of the webinar. Go ahead, Chad.
Miles, thank you very much. Welcome everyone to the third webinar on AIAG VDA FMEA. The first one was a rollout. The second one was looking at some problems and issues in terms of how AIAG VDA FMEA methodology needs to be improved. And this one is on transitioning. So, when you adopt AIAG VDA FMEA, it's got some implications, and what we need to do is prepare our organization before we transition. All right, so let's get right to it. So my name is Chad Kymal. I'm the CTO of Omnex, as Miles just informed you. I'm joined by my illustrious counterpart, Mr. Greg Gruska, who is Omnex's FEMA champion and also been on the AIAG writing committees for all the different FMEA editions, including the 4th edition. And he joined Mary Rousey, who was on the AIAG VDA FMEA writing committee, along with Mike Down, who's also on the AIAG writing committee for FMEA in doing the rollout. Greg, would you like to say hello?
Hello, everybody. Glad you were able to participate. By the way, I have with me, I'm conducting a class in PFMEA, and so I have invited the class members to view this webinar, and so I also opened it. If they have any questions or feedback, they should raise their hand and we can include them in the webinar.
Thank you, Greg. Folks, before I get started here, just a little bit about Omnex as we go through. We're founded in 1985 in Ann Arbor, Michigan. We're a global organization. One of the things how we became global is actually supporting Ford Motor Company in the emerging market strategy. We're about 700 professionals worldwide. There's a look. We don't have offices everywhere where you see a sign. We have consultants everywhere and about 18 different offices globally. All right, so this is the webinar today, transitioning to the AIAG VDA FMEA, and I'll be repeating the content in the agenda, so let me hold off on that. Let me just mention to you, in fact, Miles, if you can help me, I wanted to do a poll of how many people have attended our previous webinars. Folks, could you take a, how many of you have attended the previous webinars and how many of you are new? So it says, did you attend the previous Omnex AIAG VDA FMEA? And it's yes or no. Okay, let me wait for a minute or two. So as you do that, I'll just tell you, we have done 3 previous webinars. The first was with 3 writers of the AIAG VDA FMEA and the FMEA 4th edition, including Mr. Greg Gruska, who is doing the AIAG VDA FMEA class today. The relearning the FMEA, I actually did that for the Quality Digest. It's also available in our resource center. And really in the official series for Omnex, the second webinar we did was AIAG VDA FMEA Problems and Solutions. And I'll touch upon that. Well, actually, Greg will touch upon that as he does the first few slides in terms of how we have augmented the 7-step process to, to take care of the problems that we see with the pure AIAG VDA FMEA 7-step process. And of course, the webinar today is about the AIAG VDA FMEA implementation. So I am actually quite surprised. We had about 88% of you voted, and it shows about a little bit more than half of you are new. And folks, those of you who are new, I'd like you to know that these webinars are at our resource center. And if you have Miles Haney's email address, email Miles and he can send you a link to any of these webinars. All right, let's get started here. A little bit about myself, but you already know that. And Greg has been on the writing committees for MSA, SPC, FMEA, EFMEA, and also the MFMEA, which is the machine FMEA. Greg, what is the EFMEA, if I could ask?
No, that's the equipment. It's the same thing as the M.
Oh, same. Okay. All right. Got it. And, I've had the great pleasure of working with Greg for a very long time. Something you should also know about Greg, he worked with, Dr. Deming. So did Mike Downs. With his background, he's also worked with Dr. Deming. One of the few people alive still who had the chance to work with Dr. Deming. Greg also wrote a book about Dr. Deming, and he's one of the keynote speakers when people want, somebody who was able to speak about that. Greg, I have to say, these days, with all the new folks that we have coming into quality, I find a good percentage of people who don't know who Dr. Deming is. But we won't take the time of this webinar to tell you who he is. You should all know who Dr. Deming is and the impact he's had in quality, first in Japan, where the Deming Prize, the topmost quality award, the Deming Prize is named after him. And then, of course, the influence he had in the American industry, especially the automotive industry. All right. I want to start here with the 7-step process. And Greg, why don't you go ahead and do these first few slides about the 7 steps, and especially if you could touch on, some of the issues that we have faced and how we have augmented the process. Go ahead, sir.
All right, this is the 7-step. We did add a couple of additions. Those are called the Bs. So we have 5B and we have 7B. But essentially, the first ones this is for DFMEA, Design FMEA or Product FMEA. The first few steps are just the same as in the normal AIAG VDA. Once you get to risk analysis, one thing that we had noted is that this 5B, the linkage of special characteristics to functions and requirements. As part of the IATF, as part of the design activities, you're supposed to identify the special characteristics, and those special characteristics should be aligned or linked to the specific functions. and requirements. And so that is missing, and that's what we recommend that is included. And at the very end, when we're looking at the results documentation, the AIAG VDA does not talk about the linkages between the FMEA and the DVP&R, nor does it talk about the linkages between the PFMEA and the control plan. So as our recommendation is that we add that in as a separate sub-step.
All right, Greg. So just to summarize, you're going to learn a new term called the engineering V. If you don't, you may already know it, you cannot get the engineering V unless you add requirements to functions. In the current AIAG VDA handbook, it's optional, but we say it's not optional. You know, really functions have requirements, requirements have characteristics. So you need to add functions and requirements. And number two, also, Greg, I just want to look at the one big miss, and this is the big difference between the the VDA FMEA. As you all know, the VDA FMEA is what the Germans practiced, and the AIAG FMEA, which the US industry practiced. We adopted the VDA approach of putting all the causes in the lower levels, whereas in the US methodology, we focused on the causes at the current design. We call it the focus level, if you see that under failure analysis. So that's a big difference, that you should look at the causes in the focus level. Your design is what you can influence the most. So that's very important before you look at the lower level, which is your supplier's design, okay? Which indeed you may be responsible for, or you pretty much today, our suppliers are doing their own design. And of course, you got to identify special characteristics, very important. The design does that. And then of course, linked to the DVP&R. The DFMEA is linked to the test plan, or the DVP&R, like the PFMEA is linked to the control plan. Greg, go ahead and continue on the next slide. I added the slide in, Greg. Maybe you can tell them a little bit about the relationship between three different FMEAs so they understand why the supplier, customer, supplier, and sub-supplier are inherently linked. Go ahead.
All right, this is to demonstrate the relationship when you're doing a product FMEA, design FMEA, you need to be at the three levels. The focus level, which is the center, you need at the higher level, and then at the lower level. The higher level provides you with the effect, and the lower level provides you with the cause. But this essentially shows the cascading, because if you're starting, for example, at the brake system, the focus level, if you take it down to the next level down and say, okay, but now our focus level is the brake caliper assembly, but that would mean that the brake system itself is the higher level. So that comes straight down. There is no modifications. And so in one sense, if you start from the top and work your way down, you can actually cascade the information. So actually could make it more efficient. Unfortunately, if you're at the middle or the bottom working at it and you can't get from the customer their FMEA, you essentially have to do their work as well as your own work. And so from the brake caliper, again, the focus level now is the brake caliper, the upper level is the brake system, and the lower level is the piston. And then you can take it one step further down. And so now the piston assembly becomes the focus level. The higher level is the caliper assembly. And then the lower level is the potential cause. And this is actually an example of what Chad was trying to say, is that in this particular case, the cause is what in the design process allows the piston assembly not to transmit force. And the answer is that the design allows the piston to be stuck. It isn't that the supplier produces that, although that could be also an example, but that would be captured by the PFMEA, not the DFMEA. In this case, the DFMEA is looking into itself, into the design process, and say, why would the process not design a piston assembly which would always transmit force? And so that's the cascading effects.
Thanks, Greg. So, folks, if the brake system is the customer, the supplier supplies the brake caliper assembly, and the brake caliper assembly supplier supplies the piston assembly. And that's the conundrum we're faced with, in that especially in the DFMEA, the customer, supplier, and sub-supplier are inherently linked. And at the piston assembly level, or let's say the component level of the piston, the next lower level are the characteristics and the design of the characteristics. Anything else you wanted to add, Greg?
No, that's it.
All right. So here are the key changes to the DFMEA. Go ahead, Greg.
All right. Well, obviously, the most obvious change is the 7-step FMEA development process. The 7-step is analogous between the DFMEA and the PFMEA in that they both have 7 steps, and the latter steps are virtually the same. It is a more prescriptive risk analysis forms. It uses a action priority table that can be modified, but essentially although it does use severity occurrence detection, it goes into a table of value, which is not inconsistent with the previous versions. In fact, there are other approaches, for example, healthcare, that also uses action priority tables on there. But the thing is that because they look at the higher focus and lower level, this amounts to a 3-dimensional structure, which is really difficult to represent in spreadsheet formats. Even though the handbook says you can use the form approach, it is not as efficient as it was previously. You have to still do multiple worksheets in order to do that. I already talked about the severity occurrence detection. There are the indices, for most part, are consistent with the previous. There are a couple that are changed. It does use the index, the action priority, versus using RPN. In fact, it doesn't even calculate RPN. And it encourages the use of baseline FMEAs, the part family FMEAs. But that would require, one, is that the part family FMEA be done correctly and completely in the very beginning in order to be able to reuse the knowledge within that FMEA.
Thank you, Greg. And folks, the return on investment, is really for all of us is going to come from this idea of reuse, and, which is really emphasized in the new AIAG VDA handbook. And we at Omnex think it's a great idea. It is something we have been encouraging for a while. And for all of you, both doing PFMEAs and DFMEAs, you can save up to 80% of your cost by using the idea of reuse. Greg, we need to pick up the pace a little bit. Why don't you talk about the PFMEA 7 steps and the unique couple of things that we have added in and what we think is most important and how things are done. Go ahead, please.
All right, it essentially uses the basic 7 basic steps that from AIAG VDA. One of the things that we recommend differently is that the use of the process flow diagram. The use of the process flow diagram is only optional in the handbook, which kind of runs counter to what the PPAP requirements currently are. Because PPAP says you have to have a process flow which is consistent with the FMEA and control plan. In the function analysis, in the PFMEA, the lower level is really the 4 M's or 5 M's, depending upon how you want to look at the cause and effect structure on that. We do not recommend that during the initial function analysis that is defined, because those are really related to the specific characteristics. And unless you get the characteristics, you really cannot go down any lower than that. Failure analysis is the same as before, but when you look at causes at the lower level, and then once you've defined the causes, you can go in and populate the 4M and at the function level. Now, some people say, well, you can put in all the M's at every step or every requirement at every step. Yes, you can, but what that would do is just provide a lot of extra lines used and extra work, because not all of them come into play. In risk analysis, again, the handbook does not take into account the shop floor or the control plans. So we recommend that during the risk analysis, we plan for the shop floor control, like defining the work instructions and PM and so forth. And then finally, in 7, in the final results, we actually do the linkages of the FMEA to the control plan, to the work instructions, essentially implement what we did at 5B.
Great. Greg, I'm just going to make one comment and we'll go on. Folks, in the structure analysis, even in the DFMEA, there's an option to use the block diagram or the structure analysis. You can't really do that in the DFMEA. You have to do structure analysis. If you don't, the DFMEA falls apart. Anyway, I'm not going to go into great detail. For those of you who know, I'm just mentioning it. In the PFMEA, you actually can skip the structure analysis and go right into the process flow, which will give you the structure. So that's the main message here. Greg, I'm going to skip the next slide. I'm going to leave it in there for all of you, but I'll go right to this slide and we'll get right to the meat of what we want to discuss today, which is the implementation. Go ahead.
Well, again, the key changes we have talked about: the structure, function, and failure net analysis, which is a discipline which we have not had before, and at least in North America, although they have had it in VDA. So that is directly a carryover from the VDA stuff. People who have been used to VDA will be very familiar with that. The definitions of severity, occurrence, and detection are a lot of new verbiage, but a lot of it is still consistent with what we had in the past. In the recommended actions in the 4th edition, it was just a single column, recommended actions, and in the handbook, it is actually split between prevention and detection actions. Now, in the this would mean that it would be if you are going to do a redesign as part of your recommended action, you would have to fake it and say that's a preventive action, but which is not really straightforward. Results documentation and reporting, which is all brand new. We've never done that before. And management oversight, which was always there. The key thing that is different is that management is now required to approve that all the risk is acceptable.
Great. And folks, really, if we could say something, it would be that this is our chance to redo how we do an essential risk tool, the FMEA, and let's do it right. Let's plan it right, and let's all get the greatest benefit from doing it. And really, that's Omnex's purpose in terms of augmenting the 7 steps and this discussion today with all of you. All right, so you already understood the implications of the AIAG-VDA DFMEA in how it links the supply chain. What we'd like to do in this section is really go into the big picture, what's happening in the industry, and all of you need to know our product, the overall automotive industry product, is shifting from gas to diesel to electric and autonomous. In many ways, this AIAG-VDA FMEA is a reflection of that change. And let's quickly introduce to you one of the standards that's going to become a key part of the shift, which is the functional safety or ISO 26262, which brings in this idea of a V. So inherently, we have to create this V. What this V is, on the left-hand side, you have requirements coming down from the system to the hardware to the software, and going up the V on the right-hand side is test plans and testing for each of those requirements. All right. So there are 2 little V's alongside in the hardware and the software. That also in the hardware also there's a small V of requirements coming down and testing going up. Software requirements going down, testing going up, and then joining the system, overall system, as hardware and software gets added in. Greg, I'm going to do this fast, and then in the very end, you can add your comments or you can interrupt me as we go, okay?
Well, just the only comment I have is that this has nothing to do with VW.
That's a good one. Yes, it is to do with 3 V's.
Right.
All right. So if all of you have not seen a picture of ASPICE, today, folks, if you're strategic in terms of being successful in the automotive industry, you need to add electronics designed as hardware and software. This is ASPICE, the embedded software standard. It's a de facto standard because the European OEMs are requiring ASPICE, and Ford in the CSR is requiring ASPICE. So ASPICE it is. All we're saying is it also has a V here. If you can't see it, there's a system V, and a software V, okay? That's all I'll say. Otherwise, I'll spend too much time here. This is SOTIF, and SOTIF, the safety of the intended function, which augments ISO 26262, also has a V. And this is cybersecurity. Folks, this picture has changed. Juan Pimentel, who is in Omnex's, functional safety team, is on the writing committee. We do know the picture has changed. But just to tell you, there's also a V in cybersecurity. So what we're trying to say is how do you get this V? You get that by doing AIAG VDA DFMEA correctly, using the 7 steps correctly as we have recommended. Greg, any takeaways before I go to the next slide?
No, go ahead.
All right. So bottom line, the industry is moving to a V model approach for relating requirements and testing. And also, of course, it includes traceability. Both automotive spice from system to software requires traceability, and traceability for all requirements, folks, and functional safety just for the safety requirements. Pretty much, we have to get used to the idea that requirements need to be numbered and they need to be traceable backwards and forwards. Functional safety, SOTIF, ASPICE, and cybersecurity standards all require this. Okay? And this is the idea, and I want you to keep in mind why requirements flow down is important, is testing correctly does not happen unless you do that. And so in the AIAG VDA DFMEA, you get that by adding functions and requirements on the left-hand side in the DFMEA, and linking it to the DVP&R on the right-hand side. Where if and when you do this correctly, you get the V.
Yeah, and Chad, again, to be valid, it has to be traceable. So you just can't say, yeah, we do have the testing requirements linked to the subsystem requirements, but you have to actually show which tests support which or evaluate which failure modes or causes or so forth.
So great, Greg. I just want to have the audience follow with us what we're trying to accomplish here. Well, first is that the AIAG VDA FMEAs represent a significant change. That's number one. Number two, that the industry is shifting and requiring an engineering V, and that the AIAG VDA can give you the engineering V if you adopt this, okay? And number four, really, to do all this, you really need to have software to make life easy. You need requirements management, which I'll talk to you some more, and you need to have software that links DFMEA, DVP&R, and DFMEA to PFMEA. Let me go on. So there's a flow down of requirements. Think about the voice of the customer as being your contract, okay? The contractual requirements, breaking it down in the system, and you can have technical specifications. This is a little bit how GM does it, and actually also how ISO 26262 does it. And then subsystem to the component. So there's a flow down that happens both in the AIAG VDA and in all these new standards coming in. There's a flow down and a linkage between system, subsystem, and components. Greg?
No, go ahead.
All right. So just to tell you, this linkage between DFME and DVP&R, the third step of the 7-step process, which is called functional analysis, links the function to requirements. The 5th step, risk analysis, identifies preventive and detective controls. That's the link to the DVP&R, by the way. When you talk about controls, the controls in both the PFMEA and the DFMEA link to the DVP&R or the control plan. So these controls are the same controls in the test plan, and Omnex recommends DVP&R house both the preventive controls and the detective controls. Greg, we need to at Omnex do a little bit more research. You know, I forget now, the preventive checklist goes into a separate checklist, but I think it's good to incorporate both the preventive and the detective in the test plan, so both of them are done, and we know it's being done because that's what the DFMEA requires. All right.
You're talking about Aqua?
No. I'm just talking about methodology. That both the in the industry today in the DVP&R we usually put only the detective controls. We should start putting the preventive and the detective controls in the DVP&R.
Yeah, I agree. I mean, I've said that for years.
Great. All right, continuing along, we talked about the flow down of requirements. Now we're linking the DVP&R or the test plan to the DFMEA. Folks, now I have to go back and it's been a struggle for Omnex in the automotive industry, explaining to people first that the process flow, PFMEA, control plan, and work instructions were linked. And I tell you, we did that we came up with that discovery in the 1980s. And Greg wrote that with Ford Motor Company into the DCP, the Dimensional Control Plan, or the DCP Plus and the DCP. What time frame was that, Greg?
85.
85. And folks, we won that battle. Okay, in the manufacturing side, linking process flow PFMEA control plan, we are still fighting and making people understand something we started preaching in the 1990s, that the DFMEA and the test plans are linked, and the DVP&R and the DFMEA are linked. Why is not the industry adopted this in a big way and continued? Some of you are, most of you aren't. So this is the chance. If you want an engineering V, you have to do it. All right. So the test, you have to test both the system, subsystem, and components. And if you're coming up with the preventive and detective controls in the DFMEA, that is indeed the basis of the DVP&R. I'm not going to say anything more, but that's what we'll do in our AIAG VDA training. Any comments here, Greg?
No.
Yes. All right. Of course, this is also something very essential to what we have to do, and we have baked it into the 7-step process, that after you define the functions and requirements and you identify the 9 and 10 severities and the 8 and 7 with the occurrence, the high risk ones, you need to identify the characteristics, link it in. All right. So what we're saying in this slide is a summary of what we said earlier, that the functions, requirements, and characteristics, and the traceability between functions, testing, and testing, test methods, and the characteristics needs to be there. Okay, and that there's a hierarchy of risk in terms of ASIL levels. The ASILs come out of the functional safety and SOTF. And right now, the cybersecurity terminology escapes me, Greg, but cybersecurity will be coming up with something similar to ASILs also, and they will define for you the highest level of risk, and then you'll have important, risks, KPCs, KCCs, and all the other terminologies of all the other OEMs or your company as a second level, and there'll be a third level of important characteristics. So this requirements management, when we'll talk a little bit later about libraries, okay, of having product families and process families, this information is inherently captured in that, because you don't have to reinvent this again and again and again. It's a lot of work the first time, but it shouldn't be a lot of work after that. So that's the idea of having product families that capture these lessons learned. And when anytime we talk about lessons learned, we're saying after the DFMEA and the PFMEA are completed and we launch the product, life is like that. You're going to have failures. But the information on the failures needs to come back and update the DFMEA and the PFMEA in this fashion. Okay, here's a concern. It goes into the 8D, which then goes back into the FMEA. This is a picture of how Omnex's software does it, but it should be generally the way everybody manages. It's not possible to do this in Excel anymore, and really it needs to be done using some sort of software. This is also the idea of linkages of the documents from DFMEA all the way down to the shop floor. Okay, also very important. I keep going, Greg?
Yeah, just keep going.
Great. Folks, I have 3 parts to this presentation on transition. The first part is to emphasize the importance of managing this data that's coming out of DFMEA and PFMEA. That the DFMEA needs to essentially, the requirements flow down is captured in the DFMEA. And then to the PFMEA through just keep in mind, the essential hierarchy of requirements is functions have requirements, requirements have characteristics, okay? Characteristics are handled in the manufacturing floor. Functions and requirements are managed in the design and tested in the DVP&R, okay? On the manufacturing floor, it's characteristics, and we control it through control plans and work instructions, setup instructions, PM checklists on the shop floor, okay? All right. Now that we've got that out of the way, how we manage suppliers is through the APQP process. And this APQP process right now is one-dimensional. It only covers system. If I'm doing the system. If I'm the supplier, it's a subsystem APQP process. I hope you understand what I'm saying. What I'm saying is simultaneously the system, subsystem, hardware, software, there's a whole series of people doing design. This APQP process does not capture that. It's essentially only there for either system, subsystem, component, hardware, or software. But so there's many layers to it happening simultaneously. Keep that in mind, and that's an important discovery in your understanding of where the industry is going. All right. So what does the AIAG VDA require? A linked system, subsystem, and components via functions and requirements and failure analysis, okay? It has requirements and a failure flow down. Remember the failure flow down? We showed that to you in that picture when we showed that braking system, okay? So requirements and failures, there's a cause and effect relationship between the failure mode and the cause, okay? And the failures flow down like that. And then, of course, AIAG VDA, and we said it's a great idea, it's a good idea, it is something we really believe is very important, and you get the return on investment. Lessons learned captured in baseline of family FMEA. More than just lessons learned, it also does what is called reuse. And reuse, what does reuse do? Saves you 80% of the time, and I don't know how many millions of repeat failures, millions, I don't know, $1 million, but hundreds of failures you'll avoid if you have baseline of family FMEAs. And then linked DFMEAs and testing, and you need customer and supplier collaboration very early, right? Because as you're coming up with your AIAG, VDA, DFMEA, and the PFMEA, the suppliers need to be involved. That collaboration needs to be there. All right. What are the shortcomings in the APQP process that we are looking at currently? It does not contemplate simultaneous design of the system, subsystems, components, hardware, and software. I mentioned that earlier. I'm summarizing it now. Second, supplier selection and the visibility of the supplier comes too late in the process. This is a deficiency in the current APQP process that doesn't have supplier selection in phase 1. Okay.
Chad,
Yeah.
this is especially,
Yeah.
this is especially true because more and more suppliers are becoming design responsible. And so therefore, you're right, they should be during phase 1, because if they're going to be design responsible, they need to be part of the concept development itself.
I'll also say this, Greg, because when you're doing, in phase 2, when you're doing the DFMEA, simultaneously the PFMEA should be created. So suppliers, even if you're just a supplier who does just only manufacturing, needs to also be sourced early, right in phase 2 of APQP. So phase 1 should be design suppliers at the latest phase 2 or in the end of phase 1. And it's real important for success that the selection. The important point I was going to say, Greg, is we get a chance to work with many tier 1s. There are still tier 1s that use one supplier for prototypes and a second supplier for sourcing. Can you believe that? I thought we had abandoned that practice 20, 30 years ago. Many of you are still doing that because you haven't trained purchasing or you haven't put that into your process. That is a tremendous amount of waste and learning and you know what? To reduce your risk, the same supplier needs to do the prototype and the ongoing full production. All right. Third bullet says linkages of the documents in APQP not clearly indicated or required. Okay. APQP doesn't talk about how the DFMEA, DVP&R, special characteristics, process flow, PFMEA, control plan are all linked. And again, I'm not here as a commercial for Omnex, but I'm sorry, folks. It's just so important to how Omnex's DNA. We have been teaching this, for so many years. Greg, it took a long time for industry to catch the linkages between the process flow, PFMEA, control plan, work instructions. And, APQP needs to institutionalize that linkage.
Yeah, I agree with you. And plus in the design end too, for the DFMEA, or the block diagram, the DFMEA and the DVP&R.
Again, the block diagram anymore, Greg, cannot be optional. We need to say it's required. For the longest time, I felt the PPAP submissions need to change. There needs to be, I don't want to give away all our intellectual property, but many things need to change along with the APQP, including the PPAP. All right. There's the linkages are not there, and then a limited focus on requirements management, test plan linkage, and the control plan shop floor linkages. All these are shortcomings in APQP. Folks, why are we telling you this? As part of the transition to AIAG VDA, you need to change your new product development process to tackle this, okay? That's why we're mentioning it to you here. I'll say one more thing. This is part of the bigger change in the automotive industry. This is what you have to change as you make the shift. So why I'm saying this is you need to be considering investment, competency, and training, not just for AIAG VDA. It should be considered as a part of the shift happening, and your top management needs to be trained. They need to understand why we're doing this. So here it is, early sourcing, and the idea that the DFMEA and the PFMEA, the requirements flow down, is taking place in both phase 2 and phase 3, and there's intense collaboration going on between customer, supplier, and sub-supplier, our industry needs to change. What is happening? We're not even getting the DFMEA from our customer, right? So it is indeed a change that needs to take place to implement AIAG VDA FMEA correctly. And change management, folks, change management always had considered sub-supplier change. But I want you to understand it is essentially important because now our documents are linked. As your FMEA changes, this could be DFMEA or PFMEA, there's a supplier change, or the supplier change needs to make a customer change. So this whole process suddenly gains an importance. And that's the second part. Actually, I have two more parts. We should go fast. Let me pause here, folks. Here is actually a webinar I thought I'm going to get done early. And it looks like we would run maybe 10-15 minutes late. But I'm going to pause. I want to do it right. And I'm going to let you ask some questions and write down some questions. Okay? So
Any question?
let me pause here. I'll just say this, folks. AIAG VDA has been added to the FCA CSR. You will see many other CSR. So FCA accepts the AIAG VDA. They don't mandate it. We expect the same from the other OEMs, but let's wait and see. And what did I want to mention here? Some questions here from all of you on that. There's no mandate yet for the new format. We encourage you to adopt the new format because really, if you have European counterparts and you have both US and European customers and suppliers on the same product, you should be adopting AIAG VDA as a early adopter. And the second, of course, is if you have functional safety or cybersecurity, or if you have to do this engineering V that all leading tier ones are doing, you need to adopt that. Okay? All right. Okay, let's continue here. We'll take up the questions in the very end. All right. A very important part of the adoption of AIAG VDA is the organization of the DFMEAs and PFMEAs into the product libraries. So you need to have design and process reuse, which is important. It's a big saver of time. So this is a little bit the architecture of the linkages between DFMEA, PFMEA, and the shop floor. Okay, so in the system, there is a link between the system design and the assembly line. Okay, the process flow PFMEA control plan and the assembly line. Anytime you have a system, you're talking about assembly line. Anytime you have a component, you're talking about a manufacturing line. Okay, both of those, of course, are process flow PFMEA's control plan. And you see many players here. What manages this overall? APQP, your new product development process manages it all. In that overall APQP process are these events taking place that you have requirements management, you have DFMEAs, you have test plans, you have PPAP, you have your manufacturing group coming up with process flow PFMEA's control plan, everything linked together. And what you need to do is come up with this family of parts, between, this is a little bit how Omnex's software, manages things. On the right-hand side, you can see the parts. So you have, well, here it's showing an aerospace example, aircraft seating. Underneath it, you see all the individual seats, okay? That's the idea of the parent and the child, okay? In terms of family of parts, and the idea would be the children have all the DNA from the parents in terms of requirements, functions, failures, DFMEA, test plans, special characteristics, process flow, PFMEA, control plan, gauges, characteristics, all that. So it's a tremendous amount of information that is reused between parent and child, okay? And the idea of creating design and process documents. So it's not just documents, it is really information. Here is a manufacturing example where you can set up global receiving, global grinding, heat treat, and so on, and it's reused in the manufacturing line. All right. So how do we get started? Number one, you need to think about the competencies for top management. Top management needs to understand the implication of this AIAG VDA change. Middle management needs to understand it. They don't need to be trained tremendously, but they need to understand it. Maybe top management and middle management can be in the same half-a-day training so they understand what this transition is all about. Facilitators require the greatest amount of training. So one of the things we're encouraging is that, this is something new. If you want to institutionalize it, get facilitators trained, and then of course the team needs training, a different level of training. To help with this is how we planned what training we should do, with executive overviews at the very top, training for project team members, which are shorter, training for facilitators, which is much, much more. We have a 3-day training for facilitators, but to make you a facilitator, we actually do, inside your company, facilitation and certification. Okay, that's the way we planned it. And what you saw today in this 1-hour webinar is part of a 2-day class we're doing for managers and implementers. And lastly, the AIAG VDA introduces a new methodology called MSR. Greg, do you want to touch upon the MSR?
No, that's a whole nother webinar.
Yeah, but just mention what that means, what MSR stands for, and how it helps with functional safety.
MSR stands for Monitoring and System Response. Instead of looking at causes, it looks at what kind of mitigating activities are you going to implement, and so therefore it looks at the frequency of the occurrence and the monitoring. When you're monitoring, you have to consider the how effective is that monitoring.
Folks, because we have all these experts, Mike Down, Greg Gruska, and Mary Rousey, we already have the AIAG VDA MSR training also. All right, let's finish this up. I have 2 more slides, and then we'll take your questions, okay? Getting started, you need to start with top management, okay? Maybe you did facilitator training coming to Omnex, you're doing it on-site. We're doing many on-sites right now as we speak. But you also need to train your top management as a start. Then one of the essential steps we see is procuring AIAG VDA software that incorporates the 7 steps and that also provides linkages to DVP&R. So this is DFMEA DVP&R link and the process FIMEA and the control plan link. Then you need to change your new product development process. Incorporate AIAG VDA FMEA. You saw all the changes we need to make. Establish customer and supply chain linkages. Update your purchase order and what you tell your suppliers and your supplier handbook of the simultaneous engineering and their responsibility to work together with you in doing the FMEAs. Establish a requirements management process, and really, folks, it's too much to handle in Excel. You're going to need software for that also. And then in your AIAG VDA software, establish your libraries and reuse strategy. Again, there's so much money to be saved. This whole implementation can be a cost savings versus an investment. And again, you need this as part of the industry shift from gas and diesel to electric cars and autonomous cars. So in the end of the day, as you think all this through, simultaneously you can do your pilot, get the process in place, and then launch the program so that you get all the benefit from that. And that really, folks, is the 1 hour class that we had to do. All right, here are the main takeaways I'd like you to take with you. The AIAG VDA, DFMEA, and PFMEA represent a significant change in the automotive industry. I hope you're able to understand that. That the AIAG VDA FMEA links the customer, supplier, and sub-supplier in its inherent structure and is similar to other supply chain standards like you've heard mostly ISO 26262. You haven't heard about SOTIF or 21448. You should, you will, as time goes on. This functional safety standard came out in 2011, if I'm not mistaken. So it has taken us almost 8 years before everybody understood it. But not only is SOTIF out, there's also cybersecurity standards that are on the way that to be released either this year or early next year. So as we make this industry change to autonomous and e-cars, you know, the AIAG VDA FMEA can play an important part. How can it do that? Really, suddenly requirements management and engineering V are key changes that are required. Implementing AIAG VDA correctly will give you that engineering V. Fourth bullet, it requires software. To do a good job with these linkages between customer, supplier, and sub-supplier, you need to have software. And to manage thousands of requirements that link together, you need software. But traceability, you can't get away from it. And of course, it'll make product design and manufacturing design easy because of the reuse that comes with it. You need to train top management, managers, facilitators, and the team for overall success. The organization needs to study the 7-step process, and augment them with some of the sub-steps we have suggested. Organizations are encouraged to tackle and implement AIAG VDA FMEA systematically, make changes to purchasing, new product development, supplier management, change management, and adopt the design and process reuse process. Very quickly, you know, I am not going to spend the time actually. I encourage you to look at a second webinar to understand some of the problems and solutions that are represented by the 7-step process in this DFMEA and this PFMEA. All right. So before I go on to the questions, I just want you to know Omnex has software. Okay. We have, this is APQP and functional safety integrated software solution. We are on the process of adding SOTIF and cybersecurity. That's our goal, linking suppliers, sub-suppliers, and customers in one platform. And here is you're actually looking at our left-hand side is our AIAG VDA software for design. And this one is for PFMEAs. And remind you of upcoming webinars and the training that we have both in public training and on-site training. With that, let us go to the questions. this was a question answered. How long do you have to wait for the switching to the new format? Folks, I don't think it's going to be a mandatory requirement. If it's a mandatory requirement, we can imagine it'll come from maybe the European OEMs. But right now, there is no mandatory requirement to switch to the new format. Greg, you agree?
Yes, I definitely agree.
Okay. All right. Somebody had asked, what does functional safety have to do with AIAG VDA FMEA? Only in that both of them require the engineering V. And if you're going to do the engineering V, you need to have a methodology to do it. And what Omnex is suggesting is using the AIAG VDA FMEA for that process. All right. Greg, I'll let you take this on. What are the 5 T's?
The 5 T's. The first one is intent, which starts with an I, but they call it a T anyway. They have the intent, they have the team, they have the tasks. Let's see, got 2 more. Timing and is that tasks?
What I'll do also, Greg, is to suggest it's a detail that we don't cover in this webinar. It is covered in greater detail in the first webinar that we did in terms of rollout. So,
Right.
Mr. Dinesh, I suggest you go to that webinar and we have that. So, Brenda says, can you show me slide number 27? So let me try to do that, Brenda. Let me see here. I think this is slide 27. Slide 27 is actually the way Omnex's software links Design FMEA to the test plan. So what happens is, as the DFMEA is getting linked, the DVP&R is created, okay? And just like the process flow, PFMEA and control plan are all linked. When you change one, the others change. Same with the Design FMEA and the DVP&R linked. What we don't show you here is the requirements flow down software that links well, this is just one of them. Imagine if this is a system, simultaneously there's a subsystem like this and a hardware and a software, documents that are linked. And then finally, Brenda, it links all the way to the shop floor, and my team put in a Chinese work instruction because the software is in about a dozen different languages. All right, there you go. Actually, 2 questions on this, Greg, and about bulk materials. What is going to happen with bulk material FMEA? Do you see? I see the bulk materials maybe. Well, they do have design, and I can see the AIAG VDA DFMEA applying to bulk, manufacturers. Any comments on that?
Yeah, you can. Again, the key thing is that what is the higher level when we're doing the coatings, how it's going to be used. So you have the higher level. Why are you working or developing the coatings? And yeah, you can still do it with bulk material.
Yes, indeed. But we don't know yet, there's a bulk material. Greg, are you aware, or maybe we'll have to ask our different people keyed into these changes, of any upcoming changes happening with bulk materials? I
don't think so, because that's actually part of the PPAP stuff.
All right. So another very important question: which of the available training Omnex has would we have to do? We have a bunch of new programs coming in, and then the same person said we are not design responsible. All right. If you're not design responsible, okay, technically the customer is providing the DFMEA and COTS. So you can adopt, a couple of things. Okay, you're asking about training. I was thinking implementation. So in terms of training, to get going, I think 3 different training classes are recommended. The facilitator training, the implementers training, and then your top management training. And you can decide in which order you want to do it. I don't think you will make any mistake by if in any order of your choice you can start, but all 3 are needed and all 3 are needed together. So you do a good job adopting AIAG VDA FMEA in your manufacturing process, okay? Okay, well, let's see. If you're not design responsible, what you'll need most from your customer is this idea of design, from the design, what is the highest risk and the special characteristics. We'll reach out to you because we have your name and we can talk maybe more specifically later. What is the difference between Omnex software and Opus? I'll just give a couple of examples that I know of, Greg. Opus, I don't believe, is a web-based package. Ours is a web-based package, and you can do collaboration with the customer, supplier, and the sub-supplier, and the information is transmitted automatically between the 3. Okay, join us in the next webinar so we can tell you a little bit about our software. Opus gets very high marks. A lot of the facilitators in Europe are our own facilitators like Opus, so I can tell you that. And you know, and what else can I tell you? I don't know if Opus has DVP&Rs, and I don't know exactly how well they manage the linkages between the documents. One of the things we do, and we're prepared to do, is we think one of the ways when we teach this class, we have to teach it with software, and we are geared up to teach it with Opus. Any other comments you want to make, Greg?
No, it's getting late,
Okay.
so I
All
think
right.
we should.
Okay. Let me take 2 more questions. Questions on software, we'll get back to you. We have your name. Okay, let's see here. All right, let's stop right here. And I think we have covered, I see several repeat questions. I do see some detailed questions on RPN and things like that. Please do come to our webinar number 1, where we covered a lot about the AP versus the RPN. With that, folks, let me close this webinar and thank you all for attending. I hope you get the most out of these webinars we're doing. We have a 4th webinar coming up next, which is all about software. I know many of you have been waiting for it. We'll be happy to do that for you. So in behalf of Greg Gruska and myself, Chad Kymal, and Omnex, want to thank you all. And folks, have a great day and rest of the week. Thank you very much for joining us. Bye-bye, everyone.
Thank you and bye.